Hey, this is Mr. Aiden. Welcome back. Pre-calculus. We are in a new chapter. We're in chapter 5, which is called Analytic Trigonometry. And this is when my phone starts ringing off the hook for help in tutoring. But the amazing thing is, I feel like I teach this rather well, so I think these videos are really gonna help out big time. So we're gonna start in section 5.1, which is using fundamental identities. And we have a bunch of fundamental identities. We've gone through a lot of these fundamental identities. What do we know about the sine of u is going to be the reciprocal 1 over cosecant of u, isn't it? 1 over cosecant of u, which means cosine of u is 1 over secant of u. It's the reciprocal of that, and tangent is 1 over cotangent of u. And we know that each of these things is related to y over hypotenuse, x over hypotenuse, y over x. The cosecant is the reciprocal of sine of u, obviously. The secant is the reciprocal of cosine of u. And cotangent is the reciprocal of 1 over tangent of u as well. Okay? And we also have these things called quotient identities, which means tangent. We know tangent is y over x, which means it's really sine of u over cosine of u. And so, therefore, what is cotangent? That would be cosine of u over sine of u. And so tangent is the slope, or y over x, the change in y over the change in x, which is the sine of u over cosine of u, and cotangent is the reciprocal of that. And those are called my reciprocal and quotient identities. We also have these three identities, which is called the Pythagorean identities. These are really important, especially the first one is really important, because sine squared of u plus cosine squared of u is always equal to 1. Sine squared of u and cosine squared is always equal to 1. So if it's just a minute past 12:59 and someone asks you what's the time, just say sine squared plus cosine squared, because it's equal to 1. We also know that 1 plus tangent squared of u is equal to secant squared of u. Okay, so this is another identity. We could also say secant squared of u minus 1 is equal to tangent squared of u, or secant squared of u minus tangent squared of u is equal to 1. And we also know 1 plus cotangent squared of u is equal to cosecant squared of u. And so these are what's called the Pythagorean identities. Again, I'm going to give you a little cheat sheet for all of these identities in class. They're also on MrAiden.com. We also have what's called the cofunction identities, which means sine of pi over 2 minus u is equal to cosine of u. Tangent pi over 2 minus u is equal to cotangent of u. Secant of pi over 2 minus u is cosecant of u. Cosine of pi over 2 minus u is equal to sine of u. And these are all identities. Cotangent of pi over 2 minus u is equal to tangent of u. And cosecant of pi over 2 minus u is equal to secant of u. Okay, and those are called the cofunction identities. We also have even odd identities. We've talked about these ones before. Which one is our even functions? Well, cosine of negative u equals cosine of u, and secant of negative u equals secant of u. But what do we know about all the rest of the identities? All the rest of the identities are odd, which means sine of negative u equals negative sine of u. Cosecant of negative u is negative cosecant of u. Tangent of negative u equals negative tangent of u. That's a negative right there. And cotangent of u, negative u, is negative cotangent of u. And so these are our odd functions. Again, these are all identities. If you ever want me to show you how these identities are proven, go right ahead. There's all proofs for every single one of these functions. So let's take a look at this one. This is using the identities to evaluate a function. So we know secant of u is equal to negative 3 over 2. Now, what do we know about secant of u? Secant of u is secant is equal to the hypotenuse over the x value, isn't it? Because it's the inverse of my cosine function there. Cosine function. Sorry, I had a brain fart right there. Which means, let's think about this logically, is we know that the negative can't be associated with the hypotenuse. The hypotenuse is always a scalar quantity. It's always a positive quantity, which means my value is negative 2 in the x. Okay. Now it says tangent of u is greater than 0. And so tangent of u, where is tangent equal greater than 0 or positive? It's in this quadrant or this quadrant, isn't it? Okay, and so since the x is negative here, I know my y, I know I'm going to be in this third quadrant right here, which means my y is going to be negative as well. And my hypotenuse was equal to 3, wasn't it? Okay, and so now I can go to my trigonometric values here is negative 2 squared, that's x squared, plus whatever my y squared is equal to my hypotenuse squared, that's 3 squared. So we have 9 minus 4 is 5, so y is equal to the square root of 5, and in this case it's negative root 5. Why? Because it has to be negative root 5 because it's in this third quadrant, because I know this little stipulation right here is tangent has to be positive. Okay, so what's my sine of u equal to? Well, or sine of theta here in this case is equal to my y value, which is negative root 5, over the hypotenuse, and what was the hypotenuse? Is 3. So we have negative root 5 over 3, which means the cosecant is going to be the reciprocal of that, negative 3 over root 5, which means we have to rationalize that. We have negative 3 root 5 over 5. That's the rationalization of that. We already know the secant of u is negative 3 over 2. They gave us that, which means the cosine is going to be reciprocal of that, negative 2 over 3. And tangent is going to be the y over the x, the negative root 5 over negative 2. The negatives cancel out right there because tangent's always got to be positive, as we said, which means the cotangent is 2 over root 5 or 2 root 5 over 5 when we rationalize that. So that's example 1 right there. Example 2 is we're going to simplify a trigonometric expression. So we're just going to try to make this simplified. And so what's a way to make this simplified? Well, we have sine of x times cosine squared of x minus sine of x. What's the easiest thing to do is let's factor out a sine of x. So when we factor out a sine of x out of this first value, we're left with cosine of x. Then we have minus 1, don't we? And so now let's think about that. First thing we did was we factored. Okay, so factoring is a good thing to do. Now keep in mind that Pythagorean identity. Remember that Pythagorean identity said sine squared of x plus cosine squared of x is always equal to 1. Which means what's cosine squared of x minus 1 going to be equal to? Well, cosine squared of x minus 1 is going to be equal to negative sine squared of x. Which means what are we left with? It is we still have this sine of x on the outside, but this guy, because of the Pythagorean identity, he's changed to negative sine squared of x. And so that was because that Pythagorean identity, okay, that we did. Now, what's sine of x times sine squared of x? It's going to be negative sine to the third power of x. And that is the simplified version. And that would be simplified to just one trigonometric function right there. And so that is what we're doing when we're simplifying. We're trying to see what can we use for equalities. So here's another way we're going to try to simplify is, do you see how, or actually in this case we're going to verify, which means they gave us the answer. They gave us that it's cosecant of theta. They gave us the answer of what we want to try to get. We just have to prove it. We have to prove it. Now, you can see when we have things on the denominators, something that I want you to think is try to get common denominators. A lot of times common denominators works, okay? Which means what do we have to multiply on the top and bottom of this is sine of x, okay? So I'm going to multiply by sine of theta and sine of theta on the top and bottom right here. What am I going to multiply on this guy? Now, I'm not going to worry about this guy at the end right now. I'm just trying to get to him, okay? Which means this second guy, I'm going to multiply by 1 plus cosine of theta, 1 plus cosine of theta. Okay. Now, when I get common denominators, a little tip is don't try to multiply out the common denominators. Just kind of keep him right there. So we have sine of theta times 1 plus cosine of theta. Okay. That was the common denominator that I had. Now, what do I have on this left side here? This left term is we have sine squared of theta, don't we? Because we had sine times sine. Over here, we have plus, and let's think about this, plus cosine of theta. I'll write this out. Cosine of theta times 1 plus cosine of theta. Okay. Now, a little suggestion I'd like to make is don't distribute on the denominator. Just keep the denominator the way he was. So we have sine of theta times 1 plus cosine of theta. Just keep the denominator, and you'll see why this always happens. So now we have sine squared of theta, and let's distribute this cosine to everyone in here, which means I'm cosine of theta times cosine squared of theta. Okay? When I distributed, I had cosine of theta times cosine squared of theta. And so what do we have here is take a look at what we have. We have sine squared of theta plus cosine squared of theta. What's sine squared of theta plus cosine squared of theta equal to? That's equal to 1. There's my Pythagorean identities, which means that's equal to 1. And I'll kind of put a blue box around this. This guy plus this guy is equal to 1. So really on the numerator, I have 1 plus cosine of theta. On the denominator, I have sine of theta times 1 plus cosine of theta. Now, do you see why I didn't distribute on the denominator? Because look at what happens on the numerator and the denominator. I have a 1 plus cosine of theta. I have a 1 plus cosine of theta. What do? They cancel each other out, which is awesome, which is equal to 1 over sine of theta. And what's 1 over sine of theta equal to? Bing, 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 bing. It's equal to cosecant of theta. And guess what? I just proved this identity. I verified this trigonomic identity by getting common denominators. Okay? Let's take a look at example 4, which is factoring trigonomic expressions. So this is just like what we do of factoring. Now, look at this first one. This first one is secant squared of theta minus 1. Now, think of it. If I said x squared minus 1 and I want you to factor that guy out, well, how are we going to factor that out? What factors make up x squared? That's x and x. What factors make up negative 1 is negative 1 and positive 1. And what does the negative 1 and positive 1 do? It cancels that middle value out. Well, we're doing the same thing here, is secant of theta times secant of theta, and we're left with minus 1 and plus 1, and that cancels the middle number out. So if you have trouble factoring trig expressions, just change that trig expression into an x, and it'll really help out. So let me give you another example. Let's say we have 4x squared. So the x is standing for the tangent, plus x minus 3. Okay, now let's try to factor this nasty guy out. So what are the factors of 4x squared? Well, we could try 4x times x. We could also try 2x times 2x, but let's try 4x times x. Okay, and what are the factors of negative 3? Well, we have positive 3 and negative 1. And look at what it adds to in the middle. We have 4x times 3, that's 12x. So that's not going to work, is it? Okay, so we're going to try plus 3 minus 1, because that multiplies to become negative 3. So let's take a look. 4x times negative 1, that's negative 4x. Oh, that's got to be a positive right there. So he's got to be the positive. He's got to be the negative right there. And it takes a little bit of working out. So 4x times x is 4x squared. 4x times 1 is 4x. Negative 3 times x is negative 3x. That adds up to your positive 1x. Negative 3 times 1 is negative 3. So that worked. So now we come, and what did x stand for? X stand for tangent, didn't it? So that factors out to 4 tangent of theta minus 3. And we have tangent of theta plus 1. And you can see, anytime you're factoring trig expressions, you can change those to x's, kind of substitute. And that will really help you out to be able to factor those expressions. So let's factor another trig expression here. And you can see here we have cosecant squared of x minus cotangent of x minus 3. Now, there's a problem here, isn't there? We have cosecant squared and we have cotangent. Those are two different functions right there. Okay, and so I need some sort of equality. So let's go back to my Pythagorean identities. Okay, do you see this one right here? 1 plus cotangent squared of u equals cosecant squared of u. So let's do that over here. 1 plus cotangent squared of u is equal to cosecant squared of u. So I have cosecant squared of u, which means this is really the same as 1 plus cotangent squared of, not u, but x in this case, minus cotangent of x minus 3. Guess what? I'm now on the same playing field. I'm now dealing with cotangents, aren't I? I'm dealing with cotangent squared of x minus cotangent of x, and what do we have? Minus 2. Okay. Now, again, if you don't know how to factor this, substitute in x for cotangent. So we have x minus x squared minus x minus 2. Let's try to factor this bad boy out. What's the factors of x squared? Is x minus x. What's the factors of negative 2? Is negative 2 plus 1, which adds up to that negative 1x on the middle. Which means now let's come back to our factoring. What did x stand for? X stand for cotangent of x minus 2, cotangent of x plus 1. Okay, and that was my factoring. What did I have to do? I had to use a Pythagorean identity first to get them on the same playing field before I went and factored those nasty guys. So let's do, I think, 2 more examples here. One is simplifying a trig expression. Now, you can see here I have sine of t plus cotangent of t times cosine of t. So you can see they're all in different playing fields. So another little method to your madness. We had some methods. We have one way is let's factor. One way is let's get a common denominator. One way is let's try to change my trig functions into sines and cosines. So we have sine of t plus, and remember that reciprocal identity or that quotient identity, what was cotangent of u equal to is cosine over sine, isn't it? Times cosine of t. Okay, so now what am I left with? I'm left with sine of t. Cosine times cosine is cosine squared of t over sine of t. Okay, now do you see how all I did was I changed this cotangent of t into cosines and sines, okay, using that identity. Now I need to get some common denominators, don't I? Which means what do I need to multiply on the top and bottom over here? I need to multiply by sine of t over sine of t to get common denominators, which means I have sine of t times sine of t, that's sine squared of t over sine of t, plus cosine squared of t over sine of t. I now have common denominators, don't I? I really have sine squared of t plus cosine squared of t all over the common denominator of sine of t. Now let me ask you, what's sine squared plus cosine squared equal to? It's equal to 1. 1 over sine of t. And what's 1 over sine of t equal to? Is cosecant of t. And that is, I simplified down to one simple expression right there. One last example. We're going to rewrite this trig expression not in fractional form. So we don't like trig expressions being in fractional form, and I don't want it to be in fractional form. So what do I do if I need to get this fraction out of the denominator? Well, I'm going to multiply by the conjugate, 1 minus sine of x on the top, 1 minus sine of x on the denominator. Okay, so I'm going to multiply by the top and bottom. So the numerator here, we have 1 minus sine of x. On the denominator, we're going to do a little bit of foiling here. So 1 times 1 is 1, obviously. Because it's plus and minus, the whole reason why we do the conjugate is it cancels the middle number out. And we have plus sine of x minus sine of x. That's minus sine squared of x. Now, remember the Pythagorean identity. Sine squared of x plus cosine squared of x is equal to 1, which means 1 minus sine squared of x is equal to cosine squared of x. And I still have my numerator, 1 minus sine of x on my numerator, don't I? 1 minus sine of x on my numerator. Which means, what do I have here if I kind of undistribute the denominator? We have 1 over cosine squared of x minus sine of x over cosine squared of x. And do you see how I kind of did cosine times cosine? Okay, and you'll kind of see why I did that. What's 1 over cosine squared equal to? That's secant squared of x, because that's the reciprocal that right there, secant squared of x, minus, what's sine over cosine the same thing as? Is tangent of x. And what's 1 over cosine? It's secant of x. And so now you can see this final answer right here. There's nothing on my denominator. There's no fractional form. It's secant squared of x minus tangent of x times secant of x, and that is simplified, rewritten, not in fractional form. Okay, so that is pre-calculus, section 5.1, using fundamental identities. It's not only mental, it's fun as well. See you guys. Bye.